negative 7 outside. Only factor out the first two terms for me. And now do the same trick that we have right here. Now we only have x squared inside the parenthesis. Okay? So factor out the 2 already. Take a half of 6. Half of 6 is 3. 3 squared is 9, so I'm going to add 9 and subtract back the 9. Okay? Inside the parenthesis. Okay? And I claim this what? The first 3 terms right here will always give you a perfect square. So this is 2 times of what? X plus 3 squared minus 9, and then minus 7. You can factor it out. 2 times x plus 3 squared minus 18, and then minus 7. You guys see where I got negative 18 from? This is because what? 2 times negative 9. So this is 2 times x plus 3 squared minus 25. So this is the standard form, you see. Leading coefficient is 2, the same thing. The vertex is at negative 3 comma negative 25. Okay? So you can always convert from the general form to the standard form. Okay? The other way around is pretty easy. So you got f of x equal to x minus 2 square plus 1 minus 1, I think, in this case. And you wanna, this is the standard form, by the way. You're gonna convert it back to the general form. For this out, this is what? X minus 2 times x minus 2 and then minus 1 for you, right? X squared minus 2x minus 2x plus 4 minus 1. Then combine the like terms, you got x squared minus 4x plus 3. You get back to the general form. Okay? Same thing here. Just 4 it out and we combine the like term. Same thing. Alright. And now let me talk about one more property of quadratic function. I'll be talking about the domain and the range of quadratic function. Okay. Domain and the range. So let's start with the upward parabola. We can find domain and the range by looking at the graph. Okay. So this is upward. This is the vertex right here. In general, it's going to be h, and this is k. So for a mathematical parabola, it means it's going to go all the way from negative infinity to positive infinity. The domain will be all real numbers, so negative infinity to positive infinity. And the range, not all real numbers anymore. It's going to go up forever. But how low can it be? Can it go down to where? I'm talking about the y value, okay? This can go down up to k right here. Let me highlight it. This is the range. All the way up. Okay, so the range is from k to infinity. Similarly, what if you got a downward parabola? Okay, this point is h and this point is k. The domain is going to be all real numbers, and the range will be from negative infinity all the way to k. And pay attention that I use square bracket for k because we are including k. Okay. This is the range. It means anything. Those are mathematical quadratic function. However, when you guys see an application problem, say in economic, in physics, or in biology, whatever application you're working on, the domain may not be from negative infinity to positive infinity anymore. For example, in economic, X stands for quantity. How many items you make, and usually start from 0 to infinity, because you're not going to make like -2, -3, -4 items, okay? At least 0 and higher. It's not even real numbers, because you're not going to make like 3.504 items, or you're not going to make pi items, you make 1, 2, 3, the whole number. So it depends on a specific application. You may adjust your idea of domain and range to match up with that application. Okay, but in general, it's going to be like this. All right. Now, let me move on to the last part of our clip today. I'll be showing you some application of quadratic function. Another word, we're going to work on some word problems. Okay, I'll choose 2 typical ones. I'll put it in here. Let's take a look at the first example that we put in here. The first one is question number 3 in the book is about maximizing the revenue. Maximizing the revenue. You see that we learned about parabola, right? Parabola, you see upward like this or downward like this. Mean what? It always gives you either minimum points or the maximum point. So whenever you're talking about quadratic function, they ask you to find the maximum minimum. You are looking for the vertex, because the vertex will be either the max or the minimum, depends on the max or the min, depends on the equation, the function. Okay? So this first example, they gave you this. P is the price. Of course, we live in the US, our price is in dollars. Okay? X is a quantity. What am I writing? Quantity. Okay? Okay? And they have the equation involving X and P. The quantity is equal to -6 P plus 600. Okay? I think this is the demand equation, right? This is a linear equation, the line, okay, slope is -6, P stands for the price, X is how many items you're going to make, and the graph is going to be somehow like this. 600 is right here, okay. So, which way? Okay. Okay, looks like that. It's just extra. I didn't dare to talk much about economics because I may be wrong. You guys study economics, you know better than me. So first question, find the model that expresses the revenue. Oh, I see new thing, revenue. Question A, find a revenue equation as a function of a P, okay? And they give you a hint. Revenue is equal to P times X. Oh boy. They ask you to find the equation of revenue. Well, they give it right here, so I know that R is equal to P times X. But they ask you what? The revenue as a function of P. Another word we call at the end of chapter 3 that we learned before. We don't want to see any letters other than P in our equation because that's what they require. So everything is going to be written in terms of P. So I have to change that, and I see it right here. X is -6P plus 600. So R here is P times -6P plus 600. You technically done. Revenue in terms of P. You can simplify a little bit more. -6P squared plus 600P. I'm just doing a distribution. And I see that revenue is a quadratic function, right? -6P squared plus 6P plus 0 right here. So this is quadratic. A is -6, B is 600, and C is 0. Okay? So according to what we learned before, I know if I graph this thing, I'm going to have an upside down parabola. It's going to look like this. This is P. Oh, not X, P. P right here. This is the revenue. Okay? That's you make 0, you don't make any money. You make more. And that's up to some point. You make the maximum revenue, and then P is here the price, not the quantity. Okay? If the price is too much, then you're not going to make any revenue. Again, try to talk just a little about economics, but that is the graph. So, question B. What is the domain of R? Domain, okay? Okay, now the domain, we talk about P right here, the price. You sell something, you're not going to sell with negative price, I guess. So domain is what? Look at the function right here. From 0 all the way to infinity. Of course, if you graph it mathematically, it's going to go all the way down. So you can say what, from negative infinity all the way to positive infinity. I guess if you want to sell something, put -5, -6 price, and it's up to you. Yeah. That's the domain. Oh, I see. So I assume that R is non-negative. R is non-negative. All right. So we always take the part that R is positive. Right. We're not stupid. We're not gonna make something that's to damage our business. So R is positive. So from here to here. So the domain is gonna be from here to there. So how do you find those points? Just set R equal to 0. You can find a domain. Okay. Set R equal to 0. Do it. Negative 6p squared plus 600p equal to 0, because same thing I'm looking for what? The x-intercept, right? I call it a function. This is question B. And this is 0 right here. And this point, let's see, 600p is equal to 6p squared. Or just factor out easier. Negative 6p out, I got what? P minus 100. So I got p equals 0 right here, or 100 right there. This is the one. Okay? So the domain of the price P is going to be somewhere between $0 up to 100. Okay? And since by symmetry, I can tell you right away the maximum is going to be right in the middle. Axis of symmetry is going to be 50 right here. Question C. What price maximize the revenue? I just answered it. What price maximize the revenue is going to be in the middle. But you want to do it mathematically instead of saying by looking at the graph, you just find the vertex. This is your quadratic, right? The vertex is what? P here is negative 600 divided by 2 times negative 6. This is negative 600 divided by negative 12. This is 50. Okay? This is the vertex one right there. In other words, if you sell things at the price of $50, you're going to get max revenue, okay? The biggest revenue. And then how many units are sold at that price? So if you know the price already, look at the formula right here, x equal to negative 6. How many units? The quantity they ask you, right? So 6 times 50 plus 600, this is negative 300 plus 600 is equal to 300 items. So if you are selling 300 items total at the price of $50 each, then you're going to attain the maximum revenue. That was the idea. Okay. And then graph. Oh, I showed you the graph already. Okay. Question. What price should the company charge to earn at least $12,600? So you got the equation right here. They ask, what price should we charge to make the revenue equal to $12,600? So we plug it here. We have the revenue equation. They ask you for the price if you know the revenue. Okay, then plug in the revenue, solve the price. If the revenue R is equal to 12,600. By the way, this is problem number 3 in our book. Okay, and we have what? 12,600 is equal to negative 6p squared plus 600p. Bring everything to one side. You have a quadratic equation: 6p squared minus 600p plus 12,600 equal to 0, and solve. I can divide everything by 6. They got what? P squared minus 100p plus 2100 equal to 0. Then use quadratic formula. Let's see if we can factor this out. This quadratic formula. Okay. Oh, I can see this is 30 times 70. So this is what? P minus 30 times P minus 70 equal to 0. So P is equal to 30 or P equal to 70. The graph right 50 right here. This is 30 and this is 70. So this is going to be 12,600. So if you are selling with the price somewhere between $30 to $70, then you're going to attain the revenue of 12,600. And of course, if the price getting closer to 50, then you're going to get a higher revenue. Okay, and that is the end of the first example. You see, with like 1, 2, 3, 4, 5, 6, 7 questions in one. And the key is question A. You have the revenue function, and the rest come. Okay, let me move on. I want to go over another example in our book, another exercise actually in the book. This time it's going to be, what is it? maximum area. Okay, maximum again, max area, max area. Okay, so the idea is this. This is problem number 9. A farmer with 400 meters of fencing wants to enclose a rectangular plot that borders on a river. Okay, so this is what I see in the book. We have a river. Okay, this is a river. And the farmer is not going to fence along the river. He's going to fence 3 sides only along the river. Okay, he has total of 4,000 meters. And he's going to fence this side X. This side, for the rectangle, is opposite side is going to be equal X. 4,000 total, so this side is going to be 4,000 minus 2X, right? That's meters. Total of 4 meters. The question is, how he's going to fence his farm so that he got a maximum area out of it. Okay, you can adjust the X, right? So you can have what? You can form this way, very tiny for X and very long for 4,000 minus X, or you can do it this way. Okay, or neutralize those two. Right? X is going to be bigger, the length is going to be shorter, the width is going to be longer, or however you adjust them so that you're going to take the largest or the biggest area. So let's start with the area formula because they ask for area, right? So area is length times width, which is length is 4,000 minus 2x, and then times the width is x. This is the area, and this is 4,000x minus 2x squared. Let me arrange the term, make it look like quadratic. This is what, negative 2x squared plus 4,000x. So the area is a function, quadratic function, right? In terms of x. And if you apply what we learned before, the graph, this was going to be parabola upside down because negative 2. So that makes sense when they ask for the maximum. So how do you find the maximum? You look for the vertex again, right? That's the key, the vertex. X is equal to, or h here is equal to what? Negative 4,000 over 2 times negative 2, which is negative 4,000 over negative 4 is equal to 1,000. And I'll tell you what, if you fence this side 1,000, then you will get the maximum area. Okay? So x go to 1,000. This is the width x, right? The width. So how do you calculate the length? TH. The length is what? 4,000 minus 2x. 4,000 minus 2x equal to 4,000 minus 2,000 is equal to 2,000. So the answer is what? If a farmer has 4,000 meters fencing, then the optimization to attain the maximum area is he's going to fence the side, the 2 sides. That's what? 1 meter, 1,000 meter, 1 meter, 1,000 meters, and the length along the river is going to be 2,000 meters. Okay, parallel with to the river. Okay, so 1,000 by 2,000 by 1,000, then he's going to get the maximum area. Okay, and you see the application of quadratic function in here. It doesn't matter what you do. When they tell you a story, a problem, you try to figure out the equation or the function out of it. And with this section, the equation or the function will always of the quadratic form, okay? And either upward or downward. If it's downward like this, a is negative, then the question will always ask you to find a maximum. If it's positive, upward, which I don't see much in here, I don't see any, okay? They're going to ask you to find the minimum, okay? So it doesn't matter if they ask you to look for minimum or maximum, you really do is what? You're looking for the vertex, because that will be the point where you find the maximum minimum. In this example, they are looking for maximum, okay? Parabola, downward, so maximum. X is negative b over 2a, negative b over 2a will give you. Okay, so in this problem, what? If you fence width is 1,000 meters, the length is 2,000 meters, you can attain the maximum area. And then let me ask you, bonus question. What will be that maximum area? Yeah, you have the width, you have the length, you multiply them. You have the maximum area. The max area will be 1,000 times 2,000. It's going to be equal to 2 million meters squared. Okay? And that's the end of the story. Alright, so you see everything that you need to know for now about quadratic function and their applications. Thank you for watching, everyone. If you have any questions, please feel free to ask, especially on 4.4 right here, because I know you guys have to deal with word problems and things may get more complicated if you read the question and you may not understand completely, or you don't know how to convert from a word problem into quadratic equation to solve. Okay, so each problem will have its own difficulty. Just work on them, and if you see a problem you cannot work on it, please ask. Okay, shoot me an email, ask, and I'll try to explain them again to you. Thank you for watching, everyone, and have a good week.